So last week I talked about the definition of the Laplace transform and its overall use. What I want to talk about now in this short video is the fact that both the Laplace transform and its inverse are linear. Let me just call that a proposition. We're not going to prove it. Laplace transform and the inverse Laplace transform are linear. What does that tell us? So that tells us that the Laplace transform of a function plus another function is the Laplace transform of the first function plus the Laplace transform of the second function. And it works for minus 2. It also tells us that you can pull constants through the Laplace transform. So the Laplace transform of a constant times a function is the Laplace transform is the constant times the Laplace transform of the function. So if I had the Laplace transform of, let's say, 3 times f of t plus 2 times g of t, I could break this up over the plus sign. So this would be the Laplace transform of 3 times f of t plus the Laplace transform of 2 times g of t. And then I could pull these constants through. This would be 3 times the Laplace transform of f of t plus 2 times the Laplace transform of g of t. And we know that when we write the Laplace transform, we tend to write the Laplace transform is the capital letter of whatever function this was. So this will be 3 times capital F of the variable is now s plus 2 times capital G, the variable is now s. So the Laplace transform is linear, and same with the inverse Laplace transform. They can both be broken up over plus and minus, and you can pull constants through the both of them.